Okay, so we got another one here, but the only problem is that if I think about solving it algebraically, I got a little bit of an issue because one's sine and one's cosine. So now the extra layer I got to put on here is now I have to worry about using identities to solve these guys. So in this example, you want to make sure that you have the same trig function. Okay? And so what I notice is sine is in its basic format, so I'm going to look to replace cosine. And so I know sine squared theta plus cosine squared theta is equal to 1. And so cosine squared theta is the same as 1 minus sine squared theta, right? I just manipulate it so I move the sign over. So I'm going to go ahead and I'm going to replace. But when you do stuff like this, make sure you put parentheses because it changes the format of the problem and that 2 is being multiplied with that trig function. So we replace the trig function with this whole term. So now I got to distribute that 2. So I have 2 minus 2 sine squared theta is equal to sine of theta plus 1. Okay? So now I'm going to go ahead and I'm going to replace with just y's. Okay, so I got 2 minus 2y squared is equal to y plus 1. And now solve. So solve this guy, but remember to put that trig function back in. I'm going to move everything over to the left, to the right. So that means I'm going to subtract a 2 and add a 2y squared. Okay, so these guys would cancel out, and I am going to end up with 0 on this side, and I got a positive 2y squared plus y minus 1. And we use our factoring by grouping method because we have a leading coefficient. So I'm going to multiply these two guys together. Two numbers that multiply to negative 2 but add to 1 are 2 and 1. Actually, it's negative 1. And so I'm going to go ahead and take the 2y squared. I'm going to split this guy into the two terms that I got right here. And then I'm going to go ahead factor by grouping. So I'm going to split that down the middle. Greatest common factor on the left side is 2y. And the greatest common factor on the right side is negative 1. And now I have my two terms that I can go ahead and group together. I got the 2y minus 1 and y plus 1. So I'm going to go ahead and finish working over here. And so I'm going to solve those real quick. So I know y is equal to 1/2 or y is equal to negative 1. And I'm going to replace these, and the function was sine. Okay? And so right above this, sine is equal to 1/2. I know that coordinate, sine is 1/2 at 30 degrees, because that coordinate is root 3 over 2, 1/2. And we're all students take calculus. So that means my positive quadrants, because the 1/2 is positive, is both in first and second. And then sine is negative 1 at that point, and so that's a 270-degree rotation. So the first quadrant angle is equal to 30 degrees, and then the second quadrant angle is equal to 150 degrees. And then from this one, I get my 270 degrees, and I'm just using these values right up here because I don't have a calculator. Okay? So on to the next example. We have this one. This one's a little bit more straightforward. It's a little bit simpler than that, so go ahead, try it out. Make sure that you've got the idea down, and then watch the video for the solution. Okay, so hopefully you're checking your work here, and we're going to go ahead and balance it out. So we're going to isolate our trig function, divide out the root 2, and we're going to get cosine of theta is equal to negative 1 over root 2. And maybe you see that this is already a 45, but we can go ahead and rationalize if that makes life easier for you. and we get cosine of theta is equal to negative root 2 over 2. Okay, so now I got to think to myself, well, it's negative, so what quadrants is cosine negative in? It's cosine in the second and third, and what's my reference angle? Which is a 45 degrees, okay, because it's the root 2 over 2. So my second quadrant angle is going to be 180 minus 45, which is 135 degrees, okay, and then my third quadrant angle is 180 plus the 45, which gives me 225 degrees. If you need a little bit of a refresher on how to find a reference angle, go back to Chapter 13, look up those videos, and go ahead and get a quick refresher on how to apply the reference angles to find our solutions. But that is how we would solve. Okay, so this one's pretty straightforward. If you can do this, you're in good shape so far, but definitely need to know how to do those quadratics also. That was a pretty short video, so I'm going to go ahead and put one more. So go ahead and keep on watching. We'll have one more video in here. Okay, so this one could be a little tricky at first sight. We notice that we have two cosines set equal to each other. So this is what I don't want you to do. So first, I'm going to look at it like this. If I had x squared is equal to x, because of the quadratic, we're going to assume that we're most likely going to have two solutions, right? We're just talking algebraically here, okay? Because the highest power tells us how many solutions. Okay, so some of you might want to do this, and what I'm doing right now is wrong. Okay, I know it's wrong, but I want to show you what happens. Okay, so if I divide out an x to solve, I would get x is equal to 1, right? This would cancel out that, and these would cancel out, and 1 is a possible solution. Okay, so that might work. But what we have to be careful out is I started with a quadratic, and now I have a linear term. So I lost a solution, or I lost a root. Okay? So what we have to do is we have to be careful how we solve these types of things. What we want to do is we want to factor out a GCF. So I'm going to go ahead and I'm going to use the x squareds again. So what I do here is I put them on the same side, and I say, okay, what's the greatest common factor? It's an x. And now I can set both of these equal to 0 and solve. So you got to be careful with these kind of setups, so when you don't see a constant term, you got to be saying to yourself, ooh, GCF, I got to use a GCF. So now we know that cosine of theta is equal to 0, or cosine of theta is equal to 1. And because I got these zeros and ones, I need to think about the points on the x and y axis that are my unit circle values. And so this is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. So which solutions do I have? Well, when is x is 0? X is 0 at 90 and 270. So I know I'm going to get 90 degrees and 270 degrees from this one, or when is it equal to 1? It's equal to 1 at 0 degrees. And keep in mind that the problem was defined to be less than 360, not equal to. And these are my three answers. Okay, so I've said this in the past couple videos with trigonometric identities, and with these solving problems, you need to make sure that you practice these. If you're not practicing, you're not going to be able to work with all different types. Okay, so you got to make sure you work through the problems that I'm having you guys look at. Okay, and so this is how we solve trigonometric expressions. So this is the last example, but there will be more videos that you can look at for extra practice problems.